So let's start with something that we are well familiar with. Factorial. For those of you who don't know what factorial is, it is the product of all the numbers preceding a number till 1 and including that number. Let's say we want to find the product of 1, so it's 1 only. A base case is considered where 0 factorial is 1 as well. Now 2 factorial is 2 into 1, which is 2 as well. In the same fashion, 3 factorial is 3 into 2 into 1, which is 6. So a general way of implementing this factorial is by making a for loop. For example, let's make this loop for int I is equal to n being the number of which we have to find the factorial is greater than equal to 1 and I minus 1. Let's say p is initialized to 1 and p is equal to p into I. So after the iterations we find the value of the factorial, which would be p. So this is the general way of finding the factorial of a number. But if you want to do it by using recursion, here it is how. Firstly, it is important to know that recursion is calling a function within itself. For example, let's make the factorial function int fact int n as a parameter. So why I did this? If n is equal to 0, I told you the base case is 0 factorial is equal to 1. So if we know that n is 0, then we can directly return 1 because we know that the factorial for 0 is always 1. Else, okay, so now let's talk about a little bit of math. Here what we see is, let's make 4 factorial, so it's 4 into 3 into 2 into 1, which is 24. So here we see that 3 into 2 into 1 comes from here. 2 into 1 in this case comes from here. So we can say that 4 factorial is equal to 4 into 3 factorial, which is 4 into 6, which is 24. Directly. So using this method we can directly write n factorial for any given number is n into n minus 1 factorial. So if we implement that to our program, return n to factorial n minus 1. On this line, this function is calling itself. And just after that, the function's work is not over. It waits till the answer is returned by this function. For example, let's take the number 4. So int n is 4, is passed into this, is passed as an argument to this program. So first it checks if it's 0, it's not. So it goes to the else, and here it finds return n into factorial of n minus 1. So factorial of n minus 1 is factorial of 3. So it again goes to the first line where it calls itself. Remember, this function is still working. It's not over yet, the first function. Now we are on to the second function where n is equal to 3. If it checks if it's 0, it's not. So it goes to the else, and then it returns 4 into factorial of 3. So we know that factorial of 3 would be 3 into factorial of 2. Like this, factorial of 2 would be 2 into factorial of 1. And eventually we'll reach the factorial of 1 is equal to 1 into factorial of 0. When we reach this line, Then our program checks the if condition and it comes as true. So it directly returns 1. So 1 is returned, so to the preceding function it's returned 1 into factorial of 0, and we know the value of factorial 0, which is 1, so 1 into 1, and this factorial 1 is returned to the next function, which is 2 into factorial 1, and now we know it's 1, so 2 into 1, then the factorial 2 is 2 now, so 3 into 2, 6, then factorial 3 is 6, so 4 into 6, it's 24. So what happens in the memory of the program? So inside the memory of the program, let's say this is the memory, the first function, factorial 4, is called initially by the user. So what this function does is it calls the next function, factorial of 3, and waits for its answer. Then this in turn waits for factorial of 2, which waits for factorial of 1, which waits for factorial of 0, which we know from here is 1. So when this function returns the value, its work is done, so it gets crossed out. And it returns value to this function, which is 1 into 1, which and its work is done too, so it gets crossed out. Then by this, we finally reach this function, where we know the answer is 4 into 3 factorial, and we know the value of 3 factorial by now because of recursive iteration. So factorial 4 is equal to 4 into factorial of 3, which is 4 into 6, and now we know that the answer is 24. So by using recursion, we can do a lot of things, like we can make Fibonacci series and a lot more things, like it's used in competitive programming as an efficient tool as well. So I hope you learned something from this, and thank you.